Here I have the other type of sort, which is insertion. Insertion sort. That's a tongue twister. And what I have here is I've changed my array. I still have a 5-number array with 19 in 0, 8 in the first, 4 in the second, 25 in the third, and 24 in the fourth. So what we're going to do is we're going to walk through the insertion code process only because this second for loop with J can be a little confusing. So let's go ahead, let's set up I, which starts at 1 and goes till numbers length till it's less than. So it's going to go through 1, 2, 3, and 4. So this is a little bit different because the outside loop now is starting at the right position, and the J loop is starting at the left position. So that's the difference. The J loop, we'll jump down to that in a sec for right now, starts at the 0 position and progresses through checking each individual piece and appropriately moving the array down if it needs to. So there's 2 conditions that need to be met. So I'm actually going to delete this because I'm going to spread this one out a little bit. So I'm going to move this guy down, and we're going to add a column here that checks both conditions. So the first one we're checking is if J is greater than or equal to 0. So that is checking the array position, that J is greater than or equal to 0. So we can check that yes or no. And we can also check that numbers of J is greater than the current element. And we'll adjust this as need be. We want to check both because take a look. It's an AND situation. Both have to be true in order for the code inside to be activated. And it doesn't really like my merging, but that's okay. Let's see if this works. Yep, very good. So I'm going to progress through. We'll start at the first position of I, because we're going to have a swap right away. The number I holds, so integer current element equals number of I. So currently the number is 8, which makes the current element 8. J starts in the 0 position, so J is going to progress through each time, but take a look at what J does. J starts at I minus 1, so it's 0, and J equals 0, 0. So take a look. This prevents J from ever going past the first position in the array because 0 is the lowest position. So this will prevent our loop from progressing. So J's number at 0 position is currently 19. So is J greater than or equal to 0? Do a Y for yes. Is the number of J greater than the current element? The answer here is yes. So these two have to switch. And then I'll work through this for 25, 23. J then gets bumped down to -1. I still remains 1. The switch occurred. And this still remains 8. This still remains 8. The start number doesn't exist because J is no longer greater than or equal to 0. So that breaks the loop and puts this in its correct position. Okay? Let's look at the next one because we're going to have 2 movements because of where the 4 is at. I increases to 2. So in the second position we have number 4. The current element's number 4. J starts at I minus 1, which is 1. And that number, once again, is 19. J is greater than or equal to 0. Yes. The numbers of J is greater than the current element. Is 19 greater than 4? And the answer, of course, is yes. So, we don't actually perform the swap just yet. Numbers of J plus 1 equals number of J. So the 8's left alone. The number of J plus 1 is equal to number of J. So J right now is the 1. So this becomes 19, 19, 25, 23. Because we haven't found the spot to put the 4 yet. Because the 4 is currently hanging out with the current element. It's like a crane game where it just picks it up and holds it till we figure out where we need it. Okay, we're still on 2 with the I loop. 4 and 4. Although I is now 19, but the current holder is 4. So we could be technical there. J decreased down to 0. The start number now of J at 0 is 8. Is J greater than or equal to 0? Yes. Is 8 greater than 4? Yes. So it again moves the 8 over like that. That replaces the old 19 and moves down the line. J now becomes -1. So here we go again to that once again has the 19. Current element though is still 4. Actually, if you look at this, this never actually changes. So I can just leave those blank. 4 and 4. Number of J doesn't exist because J is no longer less than or greater than or equal to 0. So we go to this line of code here that says number of J plus 1 equals the current element. J is -1, so -1 plus 1 is 0. And that puts this in the correct position. Let's look at the other two. We'll work through this real quick. There's only going to be one more switch. You can tell that right now. The 25 and the 23 are going to switch. I is equal to 3. The 3 is 25. It is going to run through and see that the current element never is greater than, number of J is never greater than the current element, I should say. This loop starts at 2, 1, 0, and it always will run down the -1. But actually, no, it won't, because the loop will just break on the first instance. Because the start number of J is 19. Is J greater than 0? Yes, but number of J is not greater than the current element. 19 is not greater than 25, so the loop never runs. That's what happens. The loop just never runs. Because it has to be an AND situation. Both have to be true for this swap process to begin. So, on to the last one then. In the fourth position, we have the number 23. J starts off at I minus 1, so that's 3. The start number is 25. Is J greater than or equal to 0? Yes. Is the numbers of J 25 greater than current number 23? You betcha. So it again takes number of J plus 1 and moves it to number of J. So we have a 4, 8, 19, and it moves 25 over. Decreases J by 1. This is still worth 4, and our current element is still 23. In the second position, we have the number 19. J is still greater than or equal to 0. However, J's number of J, which is 19, is now no longer greater than the current element 23. So therefore, it goes to this line of code. The number of j plus 1 equals the current element. J's current value is 2. Places it properly inside the 3. And the rest gets filled in. Insertion sort is, once again, the quicker and more effective way to sort an array. And I'm about to show you this same example in the code.